There is a number that breaks the intuition of everyone who first encounters it. We know the universe is 13.8 billion years old. We also know that the speed of light is the absolute cosmic speed limit. Logic dictates that if you turn on a light at the beginning of time, it could travel, at most, 13.8 billion light years in any direction. Therefore, the radius of our visible universe should be 13.8 billion light years. But it isn't. If you look up the radius of the observable universe today, textbooks will give you a different, staggering figure, 46.5 billion light years. How can the container be larger than the distance light could have traveled since the beginning of time? Have we broken the laws of physics, or are we misunderstanding the stage upon which this cosmic play is performed? To solve this riddle, we must abandon the idea of space as a static stage. Space is not a fixed room where galaxies hang like paintings on a wall. Space is dynamic. It is alive with expansion. Imagine a photon emitted by a distant galaxy shortly after the Big Bang. This particle of light begins its journey toward Earth. For the first billion years, it travels at the speed of light, covering 1 light year every year. But here is the catch. While that photon is swimming through the void itself is expanding. The space strictly between the photon and its destination is stretching, and the space it has already crossed is stretching behind it. It is like running a marathon on a road that is being elongated by a construction crew while you run.
Let's visualize this with a classic analogy. Imagine an ant walking on a rubber band. The ant walks at a constant speed, let's say 1 centimeter per second. That's our speed of light. Now, imagine someone is slowly stretching the rubber band. If the band stretches, the destination point moves away from the ant. But crucially, the rubber the ant has already walked on also stretches. Even though the ant never exceeds its top walking speed, the total distance it ends up covering, relative to the starting point on the relaxed band, is enormous. The galaxy that emitted the light we see today was much closer to us when it released that light, perhaps only a few million light years ago. But over 13 billion years, the expansion of the universe has carried that galaxy away from us to a distance of 46.5 billion light years today.
When we look at the edge of the observable universe, we are looking at the cosmic microwave background, CMB. This is the light from when the universe cooled enough to become transparent, about 380,000 years after the Big Bang. The light from that epoch has been traveling to us for roughly 13.8 billion years. However, the regions of space that emitted that light have not sat still. They have been caught in the cosmic flow of expansion, the Hubble flow, for all that time. If we could freeze time right now and run a measuring tape from Earth to the source of that ancient light, the tape would read 46.5 billion light years. This defines our particle horizon. It is the current distance to the most distant objects we can theoretically see.
This leads to the most mind-bending realization. The expansion of space is not limited by the speed of light. The speed limit applies to objects moving through space, not to the expansion of space itself. Regions of the universe sufficiently far away are receding from us faster than the speed of light. The light they emit towards us is like a swimmer trying to swim upstream in a river moving faster than they can swim. However, because the expansion rate changes over time, governed by the interplay of dark energy and gravity, the river slows down or speeds up, allowing some of that light to eventually reach us, carrying the image of a galaxy that is now effectively unreachable. The 46.5 billion light-year radius is the result of integrating this changing expansion rate over the entire age of the universe.
So the universe is 13.8 billion years old, but our vision extends to a radius of 46.5 billion light years. This creates a sphere with a diameter of approximately 93 billion light years. This is our observable universe. It is a massive sphere of visibility centered on us. But remember, this is merely a horizon, not an edge. Just as a sailor at sea sees a horizon due to the curvature of Earth, we see a cosmic horizon due to the finite age of the universe and the finite speed of light. Beyond that boundary, there is almost certainly more universe, more galaxies, more stars, perhaps infinite in extent, whose light has simply not had enough time to reach us yet, and due to the accelerating expansion of dark energy, perhaps never will.